This explainer is based on an awesome primer on natural language processing, or NLP, by Dr. Mohammed Yousuf Ali. You know, humanity has literally always been on this quest to decode language. Think about it. We've gone from carving Egyptian hieroglyphics into stone, like the original Rosetta Stone, all the way to feeding massive neural networks with billions of lines of code. The medium shifted from rock to digital algorithms, but that fundamental burning desire to just communicate and be understood, that hasn't changed a bit. But here's where we hit a massive wall. Why is it so incredibly hard for a computer to just understand us? Well, biological expression, our language, is a total mess. It inherently breaks its own rules. It's ambiguous, deeply contextual, full of cultural slang, and relies on so much implied meaning. Computer code? It is the exact opposite. It's highly structured, purely literal, built on absolute binary logic, and demands incredibly strict syntax. It's like oil and water. So the real magic of NLP is that these algorithms have to artificially construct the intuition that you and I just naturally possess. So here is our roadmap for how we'll break this down today. First up, the cognitive bridge. Then we'll climb the comprehension ladder, check out the processing loop, explore the ecosystem of applications, zoom in on specialized NLP in healthcare, and finally, look at elevating human interaction. All right, let's start with part 1. The cognitive bridge. NLP is not just a standard software tool. It's actually the ultimate cognitive bridge. Picture it. On one side, you've got this swirling, chaotic, totally unstructured mess of human thought and speech. On the other side, a super rigid grid of ones and zeros, pure computational logic. NLP, which is a crucial branch of AI, sits right smack in the middle. It's the critical infrastructure taking our unstructured mess and translating it so a machine can genuinely understand and even generate human language. Which brings us to part 2, the comprehension ladder. Machines definitely don't just get it instantly. They have to literally learn how to process language by climbing 4 specific pillars of understanding. Step 1 is syntax and structure. Step 2 dives into semantic meaning. Step 3 expands to contextual awareness, and Step 4 finishes with disambiguation. Let's actually walk up this ladder together. Okay, Step 1, syntax. Before a machine can figure out what you mean, it has to figure out how your sentence is even built. Say you type, "The elegant algorithm translated the text perfectly." The machine has to parse that. It does what's called part-of-speech tagging, labeling the as a determiner, elegant as an adjective, algorithm as a noun. Basically, it categorizes every single word to make sure the structural foundation makes sense before it even tries to look for meaning. Once the structure is solid, we hit Step 2, semantics. Think of this like an iceberg. If someone says, "Oh, the service was entirely unbelievable," the surface level is just the literal dictionary definition, but semantic extraction goes deep underwater. It looks past the literal words to find the actual intent. It analyzes hidden relationships to figure out, hey, wait, this isn't a compliment. The algorithm actually detects frustrated intent, negative sentiment, and yes, even sarcasm. So let's expand that out to Step 3. Context. Modern large language models, or LLMs, don't just stare at one word in a vacuum. They maintain conversational context. They literally read the room. A word's meaning is influenced by the rest of the sentence, which is influenced by previous paragraphs, which is influenced by whatever situation you're in. This context is absolutely critical for these models to understand regional slang or implied meanings that change based entirely on the scenario. And that context directly solves our final step, Step 4, disambiguation. Human language is loaded with homonyms, words that look and sound identical but mean totally different things. Take the word bank. Are we talking about a financial institution, the side of a river, or tilting an airplane? If I say, the travelers stopped for a picnic by the bank, enjoying the calm flow of the water, NLP solves that puzzle instantly. It looks at surrounding context clues like picnic, flow, and water to definitively lock in that in this exact moment, bank means the side of a river.
All right, moving into part 3, the processing loop.
To really get this, we need to talk about HCI, or human-computer interaction. When it comes to language, HCI is basically a continuous processing loop. It's the real-time technical flow, where your spoken audio is converted, analyzed, understood, and responded to by a machine. This loop plays out in 3 distinct phases. First is the input. Automatic speech recognition uses deep learning to convert your spoken audio waveforms into written text. Then it hits phase 2, processing. This is where the NLP engine lives, extracting your meaning, figuring out what you want, and triggering an action. Finally, phase 3, the output. The system normalizes the text, transcribes phonetics, and a neural synthesizer generates natural-sounding audio for text-to-speech. Input, process, output. A totally seamless loop. So, where do we actually see this? Let's check out part 4, the ecosystem of applications. You can basically divide the massive NLP ecosystem by audience, so consumer versus enterprise, and by function, generative versus analytical. For consumers, generative tools are things like Siri and Alexa, while analytical tools give us grammar checkers like Grammarly. On the enterprise side, businesses are using generative customer service bots all the time, and their analytical side leans heavily on sentiment analysis, text mining, and healthcare informatics. Let's look a little closer at those. Virtual assistants are translating your voice commands into actions instantly. Whether you're yelling at Alexa in your kitchen or chatting with a banking bot on your phone, NLP is figuring out your intent and talking back. And on the analytical side, sentiment analysis is huge. Companies are scanning mountains of social media data, e-commerce trends, and product reviews. NLP sorts all of this into positive, neutral, or negative emotional tones at a scale that would literally be impossible for human beings to do manually. But it goes way beyond voice commands and sentiment. Advanced algorithms are completely changing how we communicate globally. Machine translation now uses deep learning transformer models to translate text instantly, but the real kicker is that it preserves the conversational context, rather than just doing rigid word-for-word swaps. Meanwhile, writing assistants are analyzing your context to autocorrect syntax and even suggest ways to make your writing clearer, helping you seamlessly switch from a casual text to a formal business tone. Now, let's zoom in on a really critical, high-stakes area. Part 5, specialized NLP in healthcare. The medical field is incredibly complex, right? But NLP is completely revolutionizing healthcare informatics. These specialized models are trained specifically to capture dense medical jargon. They can take completely unstructured, messy doctor's notes and extract actionable, highly structured data. That data feeds directly into electronic health records. Ultimately, this enables computational phenotyping, which is a fancy way of saying it turns chaotic medical histories into clear, searchable, and actionable patient data. This removes a massive amount of administrative friction. Think about the flow. It starts with physician dictation. A doctor just speaks naturally about a patient. That audio goes straight into a specialized NLP engine. The engine parses the medical jargon, structures it, and pushes it seamlessly right into the electronic health record. It totally takes the burden of manual data entry off the doctors, which means they get to focus on patients instead of paperwork. That is a real game changer. Finally, let's zoom out for part 6, elevating human interaction. NLP isn't just about getting computers to understand us. It is fundamentally changing and elevating how we interact with information. For one, it combats misinformation. By instantly parsing context, checking facts across vast databases, and analyzing sentiment, NLP is essentially our frontline defense against digital falsehoods. But even more fascinating, it develops our own critical thinking. Generative writing tools and syntax correctors aren't just writing for us. They're actively training us to refine our arguments and actually improving the formal clarity of human thought itself. Which leaves us with this final kind of mind-blowing thought to wrap up this explainer. We started by looking at how humans built NLP to decode our messy language. But if machines are now built to detect our sentiment, combat our misinformation, and actively refine our arguments, who is really teaching who? Are we training the algorithms, or are the algorithms now training us to be clearer, better communicators? Definitely something to think about the next time you hit tab to accept an autocomplete suggestion. Thanks so much for joining me to decode the fascinating world of NLP. Keep learning, and I'll catch you next time.